أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. وفوق كل ذي علم عليم. صدق الله العظيم. In this lesson, I am going to talk about measures of central tendency. The measures of central tendency has more than one measure. We will start with the mean. The mean is very popular and famous measure of central tendency, and the most famous one, or you can say that almost people talk about it when they talk about mean. They are talking about the average. The average, or simple average, is the arithmetic mean. For the arithmetic mean, it means simply, as you see on the screen, the sum of data values divided by the total number of observations. So if you have for example, say that you have sales results, okay, for 12 months, and if you want to get the average of these results or of this sales value, then you will simply take the total of all these sales, means that the first month plus the second month plus the third month, then take all this total for 12 months and divide it by 12. That will give you simply the average, or the arithmetic mean. So the arithmetic mean here is, as you see, equals sum. I can say simply that the total of values, which is sum, this range, divided by count, divided by the count of the same range, that will equal this result. If you look at the mean using Excel, you will see that there is the average value, the average function equals average, and highlight the whole range. It will give you directly the same result of this one. So the mean is the simple or the arithmetic average. Another type of mean, that is geometric mean. The geometric mean here means the product of values, or the nth root of the product of values. Product of values means that first value multiplied by second value multiplied by third value, and so on up to the last value. So if you take, for example, you have 10 values, so n equals 10. So if you take the nth root of the 10 values multiplied by each other, means that when you multiply values by each other, then you simply take them to the power of what? To the power of 110. This is called the geometric mean. So in this example for grades, the geometric mean here, as you see, applying this formula is open bracket, and the first one multiplied by the second one, multiplied by the third one, multiplied by fourth one, by fifth one, by sixth, by 7, by 8, then by 10. Then when you close the bracket and click shift plus 6 to get this caret, means the power of, then it will be power of what? 1 divided by 10. That will give you this result directly. At the same time, a very simple way to get the geometric mean is to apply Excel formula. As you see on the screen, it is geo mean, then highlight the whole range, will give you directly the same geometric mean. Let us go for harmonic mean. The harmonic mean is the reciprocal of the average of the reciprocals of the data values. The reciprocal means 1 divided by value. So reciprocal of value, it means what? It means 1 divided by this value. So now if we apply, let us have a look to the statistics formula. If I apply count the number of values, now I want to get the number of these grades, so equals count, then highlight all grades, divided by. Now I will take this, the reciprocal for each one, one by one. So 1 divided by the first one, plus 1 divided by the second one, plus 1 divided by the third one, plus 1 divided by the fourth one, plus 1 divided by 6, 1, and so on up to the last one. When you click enter, it will directly give you the harmonic mean, which is this value. At the same time, to make it easy, if you look at Excel formula equals Harmon and highlight all result, you will get the same. Now let us look to the median, which is other method of central tendency. This median is simply, as you see, means that it is coming in the middle of the data set. Of course, it has to be sorted, either from smallest to largest or from largest to smallest. So the median here, as you see, is 50% below the median. So 50% of the data set falls below the median and 50 above. The location of the median is the number of values. We will apply this rule. Number of values plus 1 divided by 2. It will directly give you the location of the mean. So let us have a look to these grades. As you see, they are already sorted from smallest to largest, so no need to sort them. The median here equals what? 34. If you count these values, look at count here, 34. So if you look at to apply the rule to get the location, 34 plus 1 divided by 2 equals 17.5. So what is this 17.5? 17.5, this is the location of the median. If you go to the value number 17, so let us count up to 17, it becomes 12, this one. So this is 17 and this is, so 17.5 means the value which is between 17 and the next one, and 18, this one. So the next one is 13. So what we want to get is 12 plus 13 minus 12 multiplied by 0.5, it will equal directly 12.5, as you see. So if we apply the median formula, we will get the same result, which is equals median, and highlight all values, you will get directly the result using Excel. So this is the same. At the same time, there is also more than one way to calculate the median, as we will see later in this lesson. Let us look at the mode. The mode is the highest data that is repeated, or the most frequent data in the data set. So in this example now, using pivot table, we have done what? We have taken the grades and put it on, we got the frequency of the grades. And when we right click this pivot table and click on sort largest to smallest, as you see, the data is already now, the frequency is sorted. The count of grades means the frequency of grades. So as you see that the highest frequency is 3. 3 is for number what? Number 11. That means that the mode equals 11. Now we are going to talk about decile. We have as a measures of central tendency, decile, percentile, and quartile. Decile, percentile, and quartile, they are type of quantiles. The quantile in statistics is a value that is dividing the data set into equal subsections. So, quantile is dividing the data set into equal subsections. So if the data set is divided into 10 equal subsections, that will be called decile. If the data set is divided into 4 equal subsections, that will be considered as quartile. If the data set is divided into 100 equal subsections, that will be called percentile. We have the rule to get the location of the decile. The rule is for n decile means that which decile we talk about. Is it the first one, so n will be 1? Is it the second decile, n equals 2? Is it the third decile, n equals 3, and so on? The location rule is the count values plus 1. So the number of values in the data set plus 1, that will be multiplied by n divided by 10. So, for example, the location of the second decile equals the number of values plus 1 multiplied by what? 2 divided by 10. Because we are why 2? Because we want the second decile. So n equals 2. So the second decile in this situation, or in this example here, will equal 33 plus 1 multiplied by 2 divided by 10. That will equal 3.4. So that means that it doesn't mean that 3.4 is the decile value. 3.44 in this example is what? Is the location value of the decile. So if we look at the sorted data, we have to look simply at 1, 2, 3. The third one, or the value number 3, is 2, and 0.4 means the distance between the third value and the next one, which is the fourth one. So if the third one is 2, as you see, and the next one is 2 as well, so we want 0.4 out of what? Out of 2 minus 2. That will equal exactly 2. And this is the same result as Excel formula, which is percentile.exe. So the Excel formula used to get directly the value, not the location. It means that using Excel, you do not need to look at the location of this value to get it, but Excel formula will directly give you the result or the value of the decile. The Excel formula is very simple. It is a percentile.exe. Note that in Excel there is percentile.exe and there is percentile.inc, and there is only percentile. So we are going to use percentile.exe. Then between brackets, the range. This is the range. Okay, means to select all values, and comma. Then you have to type what? N divided by 10. So, for example, if you want the first decile, then comma and 0.1 means 1 divided by 10. If it is the second decile, it will be 0.2 means 1 divided by 10, and so on. It is important to note that the fifth decile is the same as median. So look, fifth decile is same as median. So here, if we apply the Excel formula to get the fifth decile, that will equal percentile.exe, open bracket, then as you see, highlight all the whole range, comma, 0.5. This will give us 10 as a result. At the same time, the median equals median, and highlight all the range, it will give us also the same result, which is 10. So let us see how to get the first decile using Excel function. We will apply percentile.exe, and the same way highlight the whole range, comma, 0.1. So let us apply it here, as you see here. So percentile.exe, highlight the whole range, 0.1 will equal 2. It is as what? As a value. So the result of the the first percentile is 2. When we apply the decile calculation to get value of the location, sorry, to get the location, not the value, we will use, as you see here, equals count, then open bracket, highlight all cells, and plus 1 to get the number of values plus 1, then it is multiplied by 1 divided by 10. It will give us directly not the value, but as you see, the location, which is 3.4. So when we look at here, where is 3.4? This is 1, 2, 3, which is 3, 2. So the third one, as you see here, is 2. The next one is also 2. So if it is 3.4, that means that 2 plus 2 minus 2 multiplied by 0.4, it means 2 plus 0 equals 2. So this is the same, as you see here, as 2 is the same as 2, which is the result of the percentile or the decile calculation. So now we calculated the decile with 2 ways. The first one using Excel function, okay, so it gave us 2. The second one using the decile calculation, it gave us 3.4 as location, not as value. So when we look at the location in the sorted, please note that the data has to be sorted. So if you take this one, for example, this is not sorted data. So if you take copy of this one and paste it here, then go to data and click on sort, then you click on small, okay, smallest to largest, as you see here. That will give you this sorted data. So in order to look for the location, you have first to sort the data like this way, using sort in Microsoft Excel. Now let us look at the second decile. So the second decile will apply the same Excel formula for percentile, then we will get 3.8 as a result, okay, as a value. So this is as a result, not as a location. When we apply the decile calculation, it will give us 6.8. The result will be what, as you see here, equals count, then highlight all cells plus 1. It means the number of cells plus number of values plus 1. Then multiply by what? Multiply by 2 divided by 10, because we want the second decile. So the second decile means 2. The location result will be 6.8. When we look at here, 1, 2, 3, 4, 5, 6. So this is the 6. 6 is the number 3, and the next one is 4. We want 6.8, so we want 6 plus 4 minus 3 multiplied by 0.8. So it will give us the same result here as you see, which is 3.8. Let us now look at the third decile. So we will also calculate first using Excel, then it will give us 4.2 as a result. Then let us calculate using the percentile formula. It will give us the location 10.2. Then when we go to this 10, this is the 10 it is 4, the next one is 5. So 10.2 means that 4 plus 5 minus 4 multiplied by 0.2, it means simply 4.2, which is the same, as you see here, 4.2 is the same result obtained using Excel formula. Also, we can apply the same to get the third decile or the ninth decile. As you see, the direct result using Excel is 22.6. The location is 30.6. If you go to the location, the 30th one, let us count 30. Okay, this is exactly number 30. And this is the next one. So it is 30.6, means that 22 plus 23 minus 22 multiplied by 0.6, so it will equal exactly 22.6. So you saw here as how we got the decile using Excel and how we got the location of decile using the percentile calculation in statistics, and both of them is giving the same as long as we are applying percentile.exe. Now let us look at the percentile. So as I said that decile, percentile, and quartile, all of them are types of quantile. So here in this type of quantile, the data set is divided into what? Into 100 equal subsections. So the percentile indicates what is the part of data. Look at this line. The percentile indicates what is the part of data which falls below the number given as percentile. So look at this example. You scored 75% in a test, and the percentile of you is 80th. That means simply that 80% of the students in the same class scored less than 75%. So percentile is not percentage. The percentage is something else. Percentage that if you got, for example, 75 or 80 in a test out of 100, that means that the percentage of your result is what? 80%. But 80% is different from the 80th rank in percentile. Percentile is mainly showing you the rank of the data among the other values in the data set. So if your percentile in the test is 80th, it means that 80% of all students' results are falling below the result you got. And at the same time, 20%, the remaining 20% is above your result. So this has nothing to do with the percentage. In this situation, for example, if you got 70% in a score, then your percentile is 85. That means that 85 of the students got below your score, which is 70%. And 15% got above it. It means, in other words, that the test might be very difficult. But if you got, for example, 90 in a test, 90%, and the percentile of your result is 70%, the 70th percentile, that means that 70% of students got below 90%, while 30% of students got above 90%. That might mean that the test was sort of easy. It's important to note that the 50th percentile is exactly the median. So the median is the 50th percentile. So now we got to know that the 5th decile is the median, and also the 50th percentile is what is the median. Okay, now look at this question. What is the score in the 70th percentile using this data set? This data set, as you see, showing some grades. It is here unsorted, and the same grades are here sorted from smallest to largest. Okay, we are going to calculate or to see what is the score in the 70th percentile using Excel function. So we will apply percentile.exe, the same one we applied in Decile, in order to get the result will be 75.7. If we look at this data set and we round this 75.7, that means that 76, as we don't have 75.7, then 76 will be the value under which 70% of the results are falling. Now, let us use the location, the same location rule in statistics, which we used for decile, which is the number of values plus 1 multiplied by the rank divided by 100. So if we want to get the location of the 70th percentile, and we apply this formula as you see here, equals count, so the number of all cells, plus 1, so multiply by 70 because we want to get the 70th percentile. This 70 is divided by 100, it will give us as a result in the location terms what? 21.7. So now, if we look at 21.7 here, we will see that the value in the 21 order, this value, 75, and the next one is what? 76. So if we want to get exactly the percentile, regardless that is it existing on the data set or not, then we will apply the same way. The percentile, the 70th percentile will equal 75, as you see here, equals 75 plus again equals 75 plus 76 minus 75. This is multiplied by 0.7. Let us put them in two brackets. Then when you click enter, you will get to see that it is exactly 75.7, which is the result of using Excel formula. Now, an important question: what is the percentile of 76? So as you see, when you come to the percentile as one of the measures for the central tendency, you will see that you either get the value which is in the 70th percentile, for example, but at the same time you can also look what is the percentile of this value. So it looks like you are now working in two ways. For example, let us make it more clear. Say that now we have a test results for 50 students, okay? And this, okay. If now we want to know what is the percentile of the 70 or 80th, what is the 80th percentile? The 80th percentile will show you that who is the student who got the result, under which 80% of the results are falling. So for example, if we talk about 50 students, and it might be, say that, for example, it might be 72%. So that means that if it is 72%, so now 80, you talk about the 80th percentile, so that means that 80% of the student results are falling under what? Under 72%. So 72 becomes, based on the calculation as an example, is what? Is the 80th percentile. But now, in other way, say that now you have a score in this test, okay, and for example, say that you got 60%. Now we want to know what is your rank, what is your percentile, what is this 60% mean as a percentile? And this is the next question. What is the percentile of 76? Here we are going to apply this formula. It is very simple. The number the rank of the values below this result divided by total number of values multiplied by 100. So now if we look at the data, the ordered or the sorted data set, we are talking about 76. Okay, so this is 76. Let us highlight it in a different color now. Okay, this is 76. Now we want to see under this 76 how many values. If we count simply the whole values below 76, it will give us, we have 21 values. So if we go to this 21 divided by 30, as you see, multiply by 100, it will give you directly 70. That means that the percentile of 76 is 70. That means that 76 is in the 70th percentile. That means that 70% of all results fall below 76, and this is true. Look at the data set, this is 76. Look at how many values below 76, you will see that we have 21 values. How many values in the whole data set? We have 30 values. If we divide, we got equals 21 divided by 30, giving you 0.7. 0.7. That means that exactly 70% of the whole results are falling below 76. So, okay, let us go to this another example as a question. What is the percentile of 85th? Now, what is the location? Let us see the location using statistics, applying the location formula, which is the number of cells plus 1 multiplied by the required rank. Sorry, this one is not 70, it is 85. You just mistyping, so it is 85 for demonstration, and the formula is correct. Look at the formula. It is showing you count how many cells plus 1 multiplied by 85 divided by 100. So it is giving us 26.35. So this one, this is the location. This is not the result. So let us go to the value number 26 here. When we count up to 26, we will come to this one and stop, which is 88. So we have 26.35. That means that it will be 88 plus 90 equals like this, equals 88 plus 90 minus 88 multiplied by 0.35, close the bracket. It gives us 88.7, and this is exactly the result which we got using the Excel formula for percentile. Okay, let us look at the another example. What is the percentile of 30? You see that we have 30 here in the data set, and now we want to know what is the rank or percentile of this 30 among these data sets. So, how many cells now, how many values below 30? If you count the values below 30, it will give you 6. So, applying the formula will be 6 divided by 30 multiplied by 100, it will equal 20. That means simply that 20th is the percentile of the value 30. That means, in other words, that 20% of the data falls below the value 30. So I hope that you got better understanding for the percentile. Let us look at the third type, which is quartile. The quartile is also one type of quantiles in statistics, and again the quantile is a value which is dividing the dataset into equal subsections. So quartile means that dataset is divided into 4 equal subsections or parts. So now we got to know that decile means that the dataset is divided into 10 equal subsections. Percentile means that the dataset is divided into 100 equal data subsections. And quartile means that the dataset is divided into 4 equal subsections. So you have to note that the quartile is also sort of percentile. Why? Q1, which is quartile 1, means that 25% of the data falls below Q1. Q2, which is the second quartile, means that 50% of the data falls below Q2. At the same time, Q2 equals the median. So now we got to know that the median is the 5th decile and the median is the 50th percentile, and also the median is the second quartile. Okay. Q3 means that 75% of the data falls below Q3. So let us now look at this example. What is the first quartile? In Excel function, it will simply means we have 2 calculations actually to get the quartile. You can use quartile.exe and as you see here, highlight the whole range, comma. Number 1 will give you directly quartile 1, first quartile. You can also use the same one for number 2 will be for second quartile, number 3 for third quartile. And you can also use the percentile.exe to calculate the quartile as well. Maybe it might be this is easier for you because when you stick on using percentile, so when you use percentile to calculate the decile and use the percentile to calculate the percentile and use the percentile to calculate the quartile, that will make it easier for you and easy and more rememberable or rememberable, okay, than using different, easier to remember than using different calculations. So as you see here, when we apply the decile, we will simply consider that 0.25 is the first decile, and for the median or the second decile 0.5, third decile, or sorry, I'm really sorry, it is the first quartile 0.25, not decile, the second quartile 0.5, the third decile is 0.75. So this is about the quartile. You have to note that interquartile range, interquartile equals Q3 minus Q1. So now, based on this data set, if we want to, what is the interquartile? Interquartile here will equal Q3 minus Q1. That means interquartile in this data set is 44. So as you see that when you look at this interquartile, you will get to know that 50% of the data set is indicated by this quartile, interquartile. So interquartile, if you look at Q3, Q1 means that the quarter 1, 25 of the data falls below quarter 1, and Q3, 75% below falling below Q3. So the distance between Q1 and Q3 is called interquartile. Now let us go for 5-number summary. The 5-number summary consists of the following. It is the minimum, the first quartile Q1, the median Q2, and the third quartile Q3, and the maximum value. So let us apply this 5-number summary on the same data set. As you see, we will simply use min equals min, highlight the whole range, will give you the minimum value, which is 11. We will apply the first quartile, which is equal quartile.ext, and highlight the whole range, comma 1. 1 means the first quartile. We will get the median. We can apply directly the median function in Excel to get the median. Then we can get the third quartile, which is quartile.ext, and the parameter is 3. Then we can finally apply max function to get the highest value. And that's it. It's very simple. Let us see what we can do using the 5-number summary. Then we came to the box and whisker. The box and whisker here is a graph developed by Turkey Data Analysis Authority. This graph is representing graphically the minimum. The 5-number summary is represented graphically using the box and whisker. So the minimum, the first quartile, the median, the third quartile, the maximum are represented. At the same time, if the value exceeds 1.5, the interquartile range below Q1 or above Q3, then it will be outliers. Okay. So using this example, the same example, for this data set, we got this 5-number summary, as you see. Now let us see what is box and whisker. This box and whisker can be obtained directly when you highlight the 5-number summary and you go to insert, then go to statistical chart, and here you go to box and whisker. As you will see, it will give you directly box and whisker. So you don't need to make any special calculation. As you see here in this box and whisker, this is the minimum, which is 11, and this is the first quartile here, and this is the median, and this is the third quartile, and this is the maximum, which is 100. So box and whisker is representing graphically the 5-number summary, and this is the box. As you see, it is starting from the first quartile up to the third quartile, and these are the whiskers showing the minimum and maximum. So in this kind of distribution, there is might be no outliers, but if the whiskers are long, that will indicate extreme or outliers, and this can be calculated when you match the interquartile range with these extreme values. For example, here we see that the interquartile range is 44. So if the value exceeds 1.5 of the interquartile, then it will become outliers. So that means what? That means, for example, now when we look at the first quartile, it is 33.75. So if we have some values which is below, or to make it more easy, look at the third quartile, 77. So if we, for example, come to see that equals 77.75 plus the interquartile range is 44. If we multiply it by 1.5, that will equal what? That will equal this value. So now, if you look at this value now, So this can be the upper limit of the interquartile range. In our example here, the maximum value is 100. So assume that the maximum value in this example is not 100. Assume that the maximum value is 150. So I change it to make it, to match it. Now it becomes 150. Now if you look at the box and the whisker, see what happens. The maximum value becomes, it becomes 150. It's not 100. So in this situation now, we can say in this example that we have outliers. So now the maximum value becomes outlier because it is exceeding 1.5 times the interquartile range above the third quartile. Wassalamu alaikum.